Hi, my name's Andy, and one of my passions in life is playing the piano, but the other that most people don't know about is materials science. And today I'm actually investigating a very important topic in materials science, which is the mechanical properties of certain materials, specifically metals and polymers. Before I can do that today, I need to introduce you to my excellent lab team. Here are my lab assistants. I'll try that one more time. Here are my lab assistants.
Okay.
Here they are. This is Kimberly, Cassidy, and Eric. And like I said today, we're going to be investigating the mechanical properties of metals and polymers in material science. I hate it when they print the newspaper upside down. So, our first topic today is going to be elastic behavior and elastic deformation. And what elastic means in this case is reversible. Essentially what happens when elastic behavior occurs is a small load of force is basically applied to the material. And so today what we're going to be doing is modeling a metal which has a small elastic region and what happens when elastic behavior occurs in the metal. And it should be noted, however, that different materials have varying moduli of elasticity, and that's going to determine the elastic region for that specific material. So today, to help model this elastic behavior, I have my lovely lab assistant Kimberly here acting as the metal, where I'm going to act as the force. So as we can see, the force is going to be applied to the side of the metal, and the metal is going to bend. And when that force is retracted, the metal returns to its original state. So one more time, force is applied, metal bends, elastic behavior takes over, force comes back, the metal returns to its original state. Simple as that. Oh, there you are. When defining plastic deformation, you have to understand first that plastic actually means permanent. And what happens in plastic deformation is when it occurs, a force is applied to a material which causes the planes in that material to shear. And this causes plastic deformation within that specific material. So today what we're going to do with my assistants is we're going to model that. So plastic deformation is going to occur in materials, and we're going to determine which materials are more resistant and which ones aren't. So now to represent plastic deformation, I have another lovely lab assistant, Cassidy, who will be taking the place of the metal. So the only real difference in plastic and elastic deformation is there's a certain threshold of force that can be applied to the metal where it passes its elastic deformation and there's plastic deformation. And once that threshold of force is passed, it will no longer return to its original state when that force is retracted. So we'll see here, I apply the force to Cassidy's side, the metal will bend. Well, I keep applying that force, and now I take it away. However, it's deformed plastically now, and it doesn't retract when the force is retracted. And we'll see that's just how she's going to stay until the video cuts off. So, here you go. You might be wondering why I'm trying to push down that wall. Well, it goes right in accordance with what we're getting ready to talk about. It's our third topic, toughness. And toughness from a materials science point of view is the amount of energy per unit volume that a material can absorb before rupturing. And what we're going to do today is we're going to examine metals, ceramics, and polymers in terms of their toughness. And what we will see is actually that metals are more tough than ceramics, which are tougher than polymers. And for a practical example of toughness, it's going to be me versus this wall that you're getting ready to see. Ready? So needless to say, the wall was a little tougher than I was. Before I go put ice on my shoulder, we're going to look at this from a material science standpoint. So here we have Eric playing the part of the metal, Kimberly playing the part of the ceramic, and then Cassidy on the very far side playing the part of the polymer. So here we're going to see how the force is applied to the metal, and the force will continue to apply, a lot of force is being applied to the metal, then eventually it's going to rupture and break. So now we go on to ceramic, and what we should see from the ceramic is that it would take a little bit less force than the metal to actually break. So here we're going to continue to apply the force, apply it, and we see how the metal ruptured, or excuse me, the ceramic ruptured a little bit sooner than what the metal did. And now we move on to the polymer. The force can be applied to the polymer. Not that much force. We see not that much force was taken to, or not that much force was applied, excuse me, to rupture the polymer. And now we can see how the metal, the ceramic, and the polymer all have different toughnesses, being that the metal is tougher than ceramic, which is tougher than the polymer. Thanks for joining me today with our investigation of mechanical properties of certain materials and material science. And I'd like to invite you to join me on my next investigation. I have no idea when it'll be, but I can guarantee you it'll be just as interesting as the one we did today. So, I'll tell you to take care, and I'll see you next time.